Hi, I'm Ned, and I've started streaming. This is a recording from my live stream over on twitch.tv/NedMakesGames. I'm live most Mondays, Wednesdays, and Fridays at 10 a.m. US Eastern Time. I'd love to see you there. Alright, hey everybody. It's been a little bit since I've streamed. I hope you've all had a nice couple weeks. Yeah, so last week I was just super busy, and so I didn't really have a chance to stream. But yeah, so this week it's cleared up a bit, so I should be back to my normal weekend schedule. But yeah, I want to apologize for my, I know my webcam's a little blown out, but it's such a nice day today. It's been really gloomy the last couple days, and I'd hate to close the window so I can actually get some sun. But so yeah, I do apologize if my webcam looks a little strange, but we'll live with it. Also, yeah, my hair is really fluffy, but okay. So today I want to work more on my URP lit shader tutorial. I'm going to be writing the scripts, and at the same time we'll be updating the shader and these example projects to match. So what I kind of do is I add features one at a time to these projects, and then do commits on I guess my Git project local repository. And that way when I write the tutorials, or the actual tutorials on, I don't know, YouTube or whatever, I can jump around commits to get to different stages. So we'll be doing that. Okay, so like for this project is pretty big, and I've kind of split it up into 3 videos. So right now I'm working on the second video, which is about PBR lighting. And we're going to try to implement most of the features in the default lit shader. So yeah, we've got basic PBR lighting, normal maps, the metallic specular workflow, more transparency modes, emission textures, more real-time lighting, baked lighting, the depth normal pass, fog, decals, and then stereo eye support. So we'll be doing that stuff. I'd like to maybe finish all these by the end of the stream tomorrow, but that might be a bit of an ask, so we'll just see how far we can get. So I think judging by the state of these projects, I've gotten normal maps complete and working. I guess we can take a look at the actual shader code. Oh yeah, also I finally got a subscription to Pretzel Rocks, so now we won't have to see the bot chat messages every time the song changes. Okay, so let's see. Yeah, have this apply a normal map. So we sample the normal map, and then okay, so here's the function. So yeah, it takes the normal sample and it unpacks it. And then we create a tangent to world matrix, and then transform the tangent space normal to world space. And then we use that in the lighting calculations. Okay, so and then yeah, we had to add the new properties here. Okay. So yeah, we've got kind of an outline of different topics to cover. So we need to get the tangents and the vertex and the fragment. So I guess I'm talking about, yeah, we need to get the tangent here. Then we have to bring it all the way down to the fragment stage. through the interpolator structure. And then normal map and normal string properties. Oh yeah, so we have to add a define here. This is so the debugger will work correctly. Let's make sure that that is right. So we can do lighting without normal maps, and yeah, so it should be smooth. Okay, and then if I take out that define, then the lighting without normal maps shouldn't work. Yeah, okay. Just wanted to make sure that that was still correct. Alright, so let's get to writing here. So I guess I need to kind of explain what a normal map is. Let's see, so let's see. So we pretty much need normal maps to add details to meshes. So let's see. One problem games often face is slow performance. Many time. I'm trying to think. So basically, I'm trying to like introduce why you might want to use normal maps. So for instance, it might be difficult, or it might be too slow to model a ton of details into all of your assets. One way to get more detail without adding complexity to your models is with a normal map. These textures, okay, so I guess also called bump maps. These textures allow you to simulate texture on your model by specifying on a per pixel. Okay, let's see. By varying surface normal over a triangle. I don't know. This might still be too technical, but I'll come back to it. Actually, it should be, I'm going to say these textures allow you to. Okay. So how does varying the normal add detail. The normal vector is directly responsible for the amount of light a pixel receives. The closer to parallel the normal vector is to the light direction, the brighter that the brighter the shader will okay. Yeah, let's see. In PBR lighting, yeah, normal vector is directly responsible for the amount of light surface receives. The closer to parallel the normal vector is to light direction, the brighter the algorithm will draw it. So we can vary the normal vector to add shadows where bumps might appear on a surface. Okay. Let's see. So let's get started. First, add a normal, let's see. Add another texture property to your shader. Let's see. So yeah, we want to basically add this line. Yeah, this line. Okay, so there's a couple things I need to explain here. I need to explain what no normal offset, and then what the normal, or wait, no scale offset, and then what the normal tags mean. And then also this bump default I didn't explain before. Yeah, I don't know how much I want to get into like what the colors in a normal map really mean. That's not really what this tutorial is about, but I'm trying to think. So I feel like people probably just like they have normal maps that are included in the assets they might download. So I don't think I really need to explain how a normal map is generated. I guess just how to use it. Probably could do a whole tutorial on normal maps, to be honest, but let's okay, so anyway, let's not get too far ahead of ourselves. There are a few special additions we should make to this property. First, the no scale offset attribute will hide the tiling fields in the inspector. The normal map, that doesn't need to be capitalized. The normal map will use the same values as the color map. Second, this normal attribute tells Unity that this is a normal map, or that this property contains a normal map, which when importing a texture that will be used as a normal map, Unity does some extra processing to make it more efficient. This attribute will warn the user if they have not imported it correctly. Okay, there's probably a better way to write that, but I'll get it on the second pass. Okay, and then lastly, white is not a good default value for normal maps due to the way normals are encoded. Yeah, maybe we should just explain that, because I'm kind of just like dancing around it. Okay. This is done by encoding a 3D vector into a texture. The texture is read by the shader, transformed into a read by the shader and applied to the model to affect its lighting. Oh yeah, no apostrophe. Okay. So yeah, I'll probably have some graphic here because yeah, so texture values range from 0 to 1. Maybe we're getting a little ahead here. So I guess I need to explain that, like, basically the red, green, blue values of the texture are kind of interpreted as X, Y, Z values. I know that's not really how Unity does it, but that's like when you see the normal map with the kind of bluish hue, that's how it's encoded at that point. Remember, textures just contain colors, which are just sets of 4 numbers. We can store whatever we want inside those numbers, including a direction. Okay. So the texture is read by the shader with the color interpreted as a normal vector, which it then applies to the model to affect its lighting. Okay. Okay, so I guess there's a little bit more, but of course, textures traditionally can only hold numbers ranging from 0 to 1. However, directions typically have components ranging from -1 to 1. To fix this, let's see, the convention halves the vectors and adds 1/2 to all components, effectively squishing it to a range from 0 to 1. This is why actually that's not completely true, because I was going to say this is why the default color is that kind of like periwinkle blue, but actually in that case the blue vector is 1, because it's like 1/2, 1/2, 1. So how do I want to explain that? Because I wasn't going to explain tangent space until later, because kind of like my goal with this is only explain stuff when it's needed. It can only hold numbers. So if I'm going to go into all this, okay, let's see. If you've looked at a normal map, you might have noticed they're usually very bluish. This is because the blue component, interpreted as the z component of a normal vector, points directly outwards from the surface of the mesh. Usually normal maps are weighted again, I'm kind of just like explaining tangent space without explaining tangent space. Okay. Let's see. This is because the normal vectors are stored in a space called tangent space, where the z component always points outward from the surface of the model. Since the normal vectors will usually point in that direction, let's see. So obviously, I'm trying to think of how to say it. So they point like close to this direction. At least a little bit outward from the model. Blue is the dominant color of most normal maps. In tangent space, where do the x and y axes. Point. This corresponds to the UV map of your model. If you take a point, the x-axis of tangent space will point towards the direction of growing U values. I don't know if that makes sense, but I think it'll be easier to... This is something you really need to visualize, so I'll definitely make a diagram for it. Similarly, the y-axis points along growing V values. Tangent space helps us define normal vectors which depend solely on the model's surface, independent of its rotation and world space. Okay. Maybe I should move that up. But anyway, I've gotten all the ideas down. I can come back on the second draft and maybe rearrange that. Okay, so now we've explained tangent space. Okay. Second, this normal turbulent tells unity. Okay, yeah. And then lastly, yeah, so thinking back to how normals are stored in the texture, white or 1, 1, 1 will generate normals pointing, let's see, I guess diagonally out from the surface. If we want neutral normals, the texture should have values of 1/2, 1/2, 1, which appears as this periwinkle bluish color. Unity I guess properties are set the default to bump for this color to be used as the default for this texture. Okay, yeah, that's also gonna need some rewriting, but okay, so we've taken care of tangent space, taken care. Okay, I guess I gotta do the normal strength property now. Okay, we would also like to a value to turn on and off normal maps, as well as soften them if the effect is too strong. Add this normal strength property to do that. Okay, so we could kind of leave this for later, but the only reason I don't want to do that is because I call this unpack normal scale, and it expects this. So if I don't, what's it? Let me see. Maybe there's just an unpack normal function I can use. That way we can just add this normal strength later. Let me see. Core shader library packing. They have all these different encodings, which definitely won't get into in this. Okay, so they do just have an unpack normal. Okay, so let's actually change this to not use the normal strength for now. So what I need to do is take away this value and this, and then there. So we can add those back in later in the tutorial. We just make sure that works. Okay, good. And then we'll edit. I mean, I could also not have this line. Which is, yeah, probably a good point. Okay, yeah, because that's kind of don't need it for the basics of this shader, so we'll add it back in. Okay, let's make sure it works here. Okay, so yeah, so we won't do the normal strength yet. Add the texture declaration in the common HLSL file. In the forward lit pass, we need something called tangent vectors in order to convert from tangent space to world space and apply the normal vector to the model. Let's see. So let's see. The tangent vector, which gives its name to the space, defines points in the, or let's see, defines the x axis of tangent space, so it points along the direction of growing u values. This is supplied by the model data, and we can access it using the tangent semantic. Okay. Strange Okay. The tangent vector is actually float 4, but the W component contains special data. The y-axis of tangent space is defined by a vector called the bitangent. To create this bitangent, let's see. We can calculate the bitangent from the tangent vector and the mesh's normal vector, as well as this special multiplier. I don't really need to talk about cross product, I guess. Let me see. Because we never actually use it, we just use URP's built-in stuff. So just keep this in mind as we continue. Okay. We'll also pass the tangent vector in world space to the fragment function. Okay, so add field and the interpolator's structure with the text chord 2 semantic, so it very centrically interpolated. Is it? Oh, okay, it's actually text chord 3. Unity provides, I guess it's not Unity, it's URP. Provides a helper function to convert the tangent vector from object to world space. Just pass it to the vertex normal inputs function. Pass it as another argument. Yeah, because it's the second argument after the normal vector. Okay. Then set the output tangent to the value in this structure. Remember to also pass the bitangent multiplier as the fourth component. We can use this handy HLSL vector constructor to do that easily. Okay, so yeah, I don't think I've ever used this kind of Did I? No, I don't think so. Yeah, I've never used this kind of, I guess, constructor before in the tutorial. So I don't know, should I go into more detail? I mean, basically, this is a vector 3, so it sets XYZ to this XYZ, and then... Okay, maybe I should. Since the tangent supplied by URP's structure is a vector 3, this constructor will set the XYZ components to its values and add the our float as the last W component. Okay. Again, I don't need an apostrophe there. Okay. Now the fragment function has everything it needs. I guess not actually. Let's write a function. Okay. Let me see here. Okay, so I guess I don't need to set this right now because we're not doing debug stuff. So let's get rid of that and also this. And we'll add that later. And then I'll simplify this apply normal map so it won't return these. And I guess it will just return the final normal as a regular output. Okay, so this is a float 3 and this is a float 3 by 3. And then it just returns that. Yeah, so now we don't need those. And then the normal world space equals this. Let me make sure this still works in 2021. Oh, wrong file. All right. Oh, sorry about that. So I guess pretty much, I think the only difference that we did here is we added this and then we'll pass that normal like that. Okay, so we'll calculate a normal world space variable, taking the normal map into account. Write this apply normal map function, passing the mesh or the fragments normal and tangent vector, as well as the norm map sample. Okay, yeah, there's a really loud car outside my window. Apologize for that. but hopefully they'll won't sit and idle in their driveway for hours. Okay, let's see. So it'd kind of be better if I had put this like separately, but I mean, we already talked about sampling textures, so it's not, I don't know, I think this is fine. Okay, so first we need to, as I mentioned earlier, Unity encodes normal maps in a special way, so they actually don't hold straight tangent space vectors. Oh, hi, so random. How are you doing? I'm glad you could make it by today. So they actually hold, I don't think we need to get into like what the values actually are. So yeah, we can convert them back to tangent space vectors using this function from the SRP core shader library. Trying to figure out shader graph and sprite sheets. Yeah, I want to work some more with sprites and stuff in shader graph. I really haven't had a chance. But I think it would be good for that kind of thing. Let's see. Okay. So that is this line. So now we need to create a tangent to world matrix. Now, I think I say that you should know how to, let me see here. So if I expect you to know texture materials, you should know what mesh vertex is, how model UVs work. I don't really, okay, so I was curious if, well, basically I don't really want to explain how transformation matrices work. I guess I could just say this just does some math to transform. I mean, we really don't. It's not really needed to write this shader, I don't think. Okay. So to transform this vector to world space, which we have to do so it is in the same space as light direction, we can use a tangent to world transformation matrix. Don't worry, you don't need to know how matrices work. Just know it's created from the normal, tangent, and bitangent vectors and can be used to convert from tangent space to world space. This URP function will create it for you. The matrix is of float 3x3 type. Finally, URP also provides a function to apply this matrix and convert our tangent base normal. Normalize the returned value so it since rounding errors can creep up with our during all this math. Return the final world space vector. Then in the fragment function, set the lighting input normal vector to this new normal vector. In Unity, find a test normal map and in the texture importer, set it as a normal texture, apply it to your material and check it out. Now, sometimes the normal map can be too strong. Let's add a normal strength value to tone it down. All right, so before I do that, let's save the work I've done here. Okay, so commit. Okay, so basic normal maps. And then I'll create a tag. Let's see, so I'm on 10. Oh, it's gonna mess up the sorting. I should have added a 0. That's gonna bother me. Okay, and then I need to do the same here. Okay. All right, so now I need to add the normal strength stuff back in. Open up my research project scripts. I can write this myself. Strength, and then Okay. So now I should be able to turn that on and off. I'm always afraid there's going to be some weird bug that makes stuff work in 2020 but not in 2021. Even though I'm just doing little tiny changes, but I feel like I've got to build both projects simultaneously just to make sure. Okay, so that works. Okay, so add a float property in your shader file and the common HLSL file. Then switch the unpack normal function with this unpack normal scale, passing the strength. Then in Unity, you can use this value to temper normal maps or even turn them off. Okay, so finally, in Unity 2020.2, we need to do a bit more to support the rendering debugger. First of all, we need to pass it the tangent space normal as well as the tangent to world transformation matrix. To do that, let's rearrange our code a little bit. I forget, have I talked about, I don't think I've talked about out arguments yet. Okay, so I guess this is a good time to do it. But anyway, let's go ahead and, so we want to add basically this stuff back that I removed. Still don't know exactly why this needs the normal or the tangent space normal, but we'll do it. Okay, so yeah, nothing's actually happened because so need to test it in the other version. Oh wait, I didn't commit. Oh, that's annoying. Okay. It's my fault though. Okay, so oh, that was smoothness. Okay, so yeah, I need to commit the changes I did to this. Normal strength. So this will be 10 to strength. All right. Okay, so maybe it'll let me redo. So Control Y. Okay, good. So yeah, no bugs there. And then I should be able to use with normal maps. Oh, I need to add that define back. All right. Okay. We need our apply normal map function to return the tangent space normal. Okay, so the normal TS and world to tangent variables. We can do that using out arguments, which work basically the same as in C#. So rearrange the arguments and remove the type declarations. Then in the fragment function, use the new function. What's it called? Signature? Yeah, I think that's right. Then set normal TS in the surface data. Okay, actually, yeah. World to, or tangent to world. And the lighting input, but only in 2021.2, and normal TS in the surface data. Back. Oh, right. Then we need to signal to the debugger that we have a normal map in effect. We can do that by defining this keyword in the shader file. Alright, so now back in Unity, the renderer debugger can provide us interesting views, like the tangent space normal view and lighting without normal maps. Okay. Is there a tangent space normal? Yeah, right there. Okay. I don't know what that up was supposed to be. Alright, well that took a bit more explanation than I was expecting. But I guess I did have to explain tangent space and stuff, so... yeah, I need to go back over that and maybe clean some of it up, but we'll do that some other point. Okay, so let me just make sure. So we got the tangent vector and vertex of fragment. Okay. Alright, so we're good. So what's next on our outline? Okay, so metallicity and the specular workflow. Alright, so before we start writing, let's implement it in our shader. Okay, so yeah, before I go any farther, I need to commit these changes. Okay, so normal debugger views. This is 10.3 debug. Okay. Let's take a look at what we've got to do for this. Okay, so we have, here you can see we have a local fragment specular setup. And then I have surface type. I know most of it is in the editor script. Oh, okay, maybe not. Do I just do it? Oh, this is the... Oh, here, yeah, I just do a toggle keyword. And then, yeah, depending on specular setup, we pass different information to the surface input. Okay, and then we have the extra texture. Okay. So first off, I guess I'll need all this stuff. Then our shader feature. So what this does, So when we turn this toggle on and off, we enable or disable this keyword. And so the shader feature specifies that Unity should compile a version of the shader with and without the keyword turned on. Okay, and then oh yeah, I've got to add all the properties here. And then the sample. Okay, we'll try to make sure I get it kind of in the same spot as before, so that the shaders end up to be about the same. Okay, so I think that's all I have to do. So in case you're not aware, the metallic and specular workflow are basically two different ways that you can specify like special textures for your PBR material. In the specular setup, this texture has like colors for the specular highlights. So yeah, and that's kind of what this is. It's a specular color. Oh, let's see. How do I definitely don't want to overwrite it. I should put alpha way down there. Well, this will, I guess. Oh, whatever. Oh yeah, and then also add in smoothness. I guess I'll just go ahead and kind of rearrange a little bit. So for some reason I put tangent normal up there and alpha. Okay, well, whatever. It doesn't really matter the order. Okay, so yeah, so that's the specular setup, but then also the metallic setup. You can just specify like a metallicity, which makes the specular highlight just behave a little different, and it has more reflections. So they're kind of just like two different ways to work. It'll show off both ways, obviously. So is that all? Okay, yeah, so right now it's fully metallic because the specular map is set to white. So I can turn this down and it's goes back to normal. But then if I turn on specular workflow, then we can see that the okay, well, that's not right. It shouldn't overwrite the albedo texture that much. It should just like color the highlight as white. Okay, what am I forgetting? that how it's supposed to work? Okay, maybe that is how it's supposed to work. Maybe I just don't understand. I usually work with a metallic workflow. Okay, I guess I can test it. Let's see how like something similar with the default lit sphere looks. Okay, I guess this one's... Oh, let's just create another one because I can delete it later. So I want it to be as close to mine as possible. And then we'll use the specular workflow. Okay, so that's definitely not right because here... Oh, let's see. Okay, the specular map is actually... Okay, no, that is correct. Okay, I guess I just didn't understand how it worked. Okay, so it looks a little different, and that's because we don't have baked lighting on our materials yet. Okay, so yeah, I guess you just don't want to have fully white. I guess if you do that, then you're just turning it into a metal in the specular workflow. Okay, well, that's interesting because I misunderstanding that. Okay, so anyway. Like this, you can use this dot texture, and the kind of cool thing about this is because of the alpha channel, we can change the smoothness so certain parts are more shiny than others. Anyway. Okay, so I think that's all I have to do for this. Okay, so let's see. With PBR textures, you might have come across metallic maps. These textures allow you to set the metallicity of your material, making it more reflective. Wait, I don't need a comma there. let's implement them. Okay, so I guess I'm gonna kind of delete the work I just did because I want... So first I think we'll just do a metallic workflow, and then we'll add in the specular. Workflow, and then I'll add in the smoothness to it. Okay, so I mean technically we should rename this because it's only going to have metallic. I don't really want to do that because I'm going to have to change it every time I add something, but I guess that's just how it has to be. So yeah, this will be the metallicity map. We'll get rid of this. Okay, we'll still have this multiplier. We don't need the specular tint. Don't need... that's annoying. I accidentally just stopped recording, but okay, it's fine. I'll just splice them together. Alright, got that. And then, so we get rid of the specular tint, change this to just the metallic map. Okay, we'll get rid of this comment for now. And then here, so no specular setup. Okay, I had specular to 1, so we'll just leave it. It doesn't matter for metallicity. Okay, so let's see. Oh yeah, and then we don't do that either. Oh, right. Okay, so let's test this real quick. Set the metallicity map to the rainbow, so the red area should be more metallic. I think that's what's happening. Yeah, you can tell with the highlight. Okay, so in your shader file, add another texture property for the metallic map. While you're here, add a property for metallicity multiplier. Then add these 2 new properties to the the common HLSL file. And your fragment function sample the metallic map, then multiply. Okay, so metallicity is a single float value, so we'll store it in the red channel of this texture. Multiply that with the metallicity multiplier and set it in the surface data. Okay. Is that it? I feel like I'm... Okay. So I'm still calling this metallicity, specular smoothness. Okay, I guess I'll be good. I don't really... I mean, I guess we could explain like what this actually does to the lighting, but you could kind of just treat PBR as a black box. You don't really have to know. So I think this is fine. We don't really do any math with it because we kind of had to know what texture space was because we're actually working with it, our tangent space. We don't really need to know how the metallic values affect the final color. So I don't think I'll explain that. Okay. That's it. Back in Unity, add a texture for your metallic texture in your material. Since we're not using this texture as a color, it's a good idea to turn off sRGB. Turn off the sRGB setting in the texture importer. Unity does some extra processing to color textures to have them look their best, but we don't want it to touch textures used as data. This setting, our turning off this setting will preserve texture values. Okay, so regardless, check out your shader. Metallic areas will have different looking specular highlights, and they will appear more reflective when we add reflection support down the line. Yeah, I don't think it'll work right away. Well, it might actually, but I haven't baked anything in this scene yet. Okay, 1 second. My nose is super stuffy, so just give me a second. Alright, well that's a little better. Okay, so yeah, we just finished with metallic. So now I need to, I guess I should have made sure all these changes worked in 2021. It looks different. Is it maybe the smoothness? Because here the highlight okay. Yeah, so that little bit made the highlight a little bit more apparent. Okay, so I just want to make sure. Okay, so let's save these scenes and then commit changes. So metallic texture. Okay, so it was 11, I think. Oh, okay, it actually does keep it sorted the way I wanted. That's nice. Okay, so 11, 1 metallic. Oh, but I want it to be based on the head. Okay, so now I want to add back in, I guess, do I want to do, I guess specular workflow. I was gonna, we could do smoothness next, but okay, so for this we need specular tint, and also let's toggle. Oh, I accidentally left this comment in there. Okay, and then also, yeah, we don't do smoothness yet, so. Then here I need to change this to metallic spec. And then float 3, specular tint. I guess let me make sure that that's what I called it. Oh, it's actually float 4 though. And then in the forward pass, oh, it's actually here. Okay, yeah, no smoothness yet. Okay, so I think that should be oh, extra underscore in there. Right, and then yeah, if I turn on the specular workflow. Oh, I forgot the shader feature. Okay, so now it has that kind of weird effect, but we can just turn the specular tint down. Definitely has an interesting effect. I want to look into the math later and see exactly how that works. Yeah, so that's interesting. So if you set the specular color the same as the surface color, it basically makes it look like as if you had it on full metallic. Anyway, it's enough playing around with that. Okay, so basically got specular set up. So let's add it to the 21 version just to make sure. Oops. Yeah, that was the wrong file. And then let's open up the rendering debugger. Okay, smooth this not affected yet. Okay, as you can see, the specular color is this kind of maroon, which is reflected there. So yeah, if I put in the dots, it's kind of strange. That's because it's not taking the alpha into account. Yeah, there's a rainbow. Okay, it does have metallic, but since this doesn't have a metallic workflow, if I said, yeah, so you can see how that works. Okay. All right, so you may or might have heard of the specular workflow if you've ever worked with URPs or if you've ever worked with PBR before. This is an alternate way to define reflective surfaces using a specular color texture. It can achieve the same looks as where the metallic workflow is simple, only needing one value to achieve a metallic looking surface. The specular workflow allows you to define a color for specular highlights. It can also achieve, let's see, I think that's the wrong way to say it. So it can achieve the same look as the metallic workflow, but is more complicated since you define to create a color texture instead of a grayscale. We can support both. Our URP supports both workflows, and we can too. First, we can reuse the metallic map as the specular map when in the specular workflow. Let's rename it to reflect that. Now we need a way to switch between the two modes. We can use a keyword and shader feature like we did for alpha cutouts. To toggle, okay, let's see. Notice the fragment suffix on this pragma. That tells Unity that the keyword is only used in the fragment stage, allowing it to do some optimizations. Okay, so we can turn this keyword on and off really easily using a property. Define a float property and tag it with this toggle, what's it called? Attribute. Inside, you can specify the keyword to turn on and off. Specular workflow and oh wait, no, it's specular setup in this case. The name is important since the PBR function changes based on this keyword. Okay, so we did all that, and now let's see. So update. Oh, okay. Let's also add a specular tint property to modify the specular color. Update the property declarations in the common HLSL file. Then in the fragment function, update the texture and the sampler names. Okay, let's. Okay, don't need so. We need to pass different values to the PBR function depending on the. Well, I kind of wonder actually. The only reason I've done this is because it's like this in the lit shader. But I mean, really, I don't know. I feel like we could just combine these together and do something like this, but I don't know. This is how the default shader does it, so I'll just keep it. Okay, yeah, so depending on the workflow, if specular use an if def command for that. In specular mode, set the specular color to the RGB channels of the texture multiplied by the tint and the metallic value to 0. Otherwise, we can use our old code for the metallic workflow. All right, so I think that's it. Back in Unity, try different combinations of textures, tints, and workflow to see how these options affect your model. There's no wrong answer. I've seen metallic and the specular workflows in use before, so use whichever you prefer. Okay, so before we move on, notice that neither workflow uses the alpha channel of the metallic specular texture. This is a shame. It's wasting that space for nothing. Remember, textures just contain colors, which just contain numbers, so we can use the alpha channel for anything. So far, we don't vary smoothness over the model. So let's use the alpha channel for that. First, in your shader file, okay, let's first rename the metallic specular texture one last time to signify it also contains smoothness. Before I go farther, I should commit the changes I did. Let's see. Okay, let's save these. Okay, so specular workflow. Okay, it's 11 to specular. Okay. Yeah, so let's add smoothness, which basically I just gotta add smoothness here and here. Okay, so MSS sample.a. Because I should make sure this is how I actually wrote it. Oh, right, it's in the common file, so yeah. Okay, and it already showed up because I had this dot texture in there. Okay, so let's add this to the 2021 version just to make sure. All right. Okay. Okay. Then multiply the alpha channel with the smoothness property when calculating smoothness in the surface data. Back in Unity, try out a channel or a texture with an alpha channel to see your changes in action. This technique of using texture channels for different effects is called texture packing, I think, or maybe channel packing. I don't know. I'll look that up later. and is a very useful optimization technique. We want to sample as few textures as possible, and whether we use one channel or 4 channels takes the same, well, this isn't completely true, but same amount of time generally. Okay, so we're done with this. I guess before I move on, let's commit to this. So smoothness, texture, and it'll be 11.3 smoothness. All right, so what's next? Okay, more transparency. So right now we implement transparency only blended or cut out. And so the blended mode, there's a couple more effects you can do. Let's see here. You can kind of see on this camera. If I can find the material for it. Okay, so let's have this transparent blend. Yeah, so right now we have it set to transparent blend. We can, so we can set it to just alpha mode, which you really can't see much. But then when we set it to pre-multiply mode, what it does is it decreases transparency on areas that receive specular highlights, so it makes it look more like glass. So we'll do that, and then there's also additive mode, which you can't really see here. Let me see. Okay, there we go. So what this does is it just adds the color on top of what's behind it. Not sure. I'm not sure why I can see anything behind it right now because I have it set to fully alpha. That's probably something I'm forgetting. But anyway, so that's what additive is, and then multiply. Yeah, it just multiplies red with what's behind it. Okay, but now I'm afraid that I have a bug, so... Okay, let's change this back to pre-multiply. Let's add a plane. So I just want to put it in front. Okay, let's just make a test material. Probably delete this in a second. Sometimes I can see behind it. Is it just an editor thing? Oh, it's okay. I'm seeing the screen space ambient occlusion because transparent blend materials don't write to the depth buffer. So yeah, if I turn off screen space ambient occlusion. Oh, that was screen space shadows. Yeah, here. Then you don't see it. Okay, so that's all that was. Okay, I feel good about that. And if I turn down the alpha, then you can see through. Then yeah, if we have pre-multiply, areas that get specular highlight, it's kind of hard to see here just because it's a flat color, but it became more opaque. And even when I set alpha to 0, it doesn't really change much. And that's because it's getting a lot of highlights from the light. Additive, it just adds 1 to it, but it kind of blows out the camera or the color because I'm adding pure white. So you can see if I just add red, then multiply. Kind of cool effect. Okay, so anyway, we'll add this now. Delete, and then we'll just delete this plane. Okay. Okay, so I think pretty much most of this is in the I think most of this takes place in the editor script, the inspector. Okay, so what have I done so far? Okay, so I don't have that enumeration. So yeah, basically down here in transparent blend, we need to implement almost all these effects just by changing the source and destination blend types. But then the pre-multiply, we have to add a keyword because the PBR implementation actually changes the alpha based on the specular color, like I said before. So we enable that with this keyword. Okay, so let's just add that. I think this is like the last time we're gonna... Oh no, we're also gonna do this. Okay, I was gonna say the last time we're gonna touch the editor, but not quite. I did. Yeah, I committed. Okay. So, I mean, I guess we can pretty much just implement all of these at once. I don't think there's really a reason to do one at a time. Yeah, because it's pretty not that difficult. So we have that. Accidentally, I already included the blend type, I think, in the shader. But I should be able to remember to remove it in the actual tutorial. Oh. Okay, I don't know why it didn't want me to press enter there. this last bit for the keyword. Okay. And I think that's it. Okay, and then on the shader. So we would need to add this blend type, but I accidentally already added this. In fact, I think I'll just write a note here. Remember to remove from previous. Oh, that's not even gonna help because okay, I need to like write a note in the script. I could have already done that actually. Let's see. So if it happens, yeah, here. I'll just write a note here. Remember to remove the blend type property from example code. Okay. And then I need to add this keyword. I think that's it. Yeah, I think that's all I have to do. I don't need to change anything in the fragment function, if I remember correctly. Great. Okay, so let's use this one as our transparent sphere. So we'll set a transparent blend. Because right now it's on alpha. And then pre-multiply. Okay, I don't think that's correct. Additive is good, I think. And then multiply. Yeah, it only shows up on areas that are already sort of reddish. Okay, so the pre-multiply is not right because it's not affected by this alpha value. So let me see. What am I forgetting? Search for this. Okay, it's already starting to search. Oh, you know what? I didn't. Okay, I do need to add this. Oh, no, I don't. I was going to say I need to add it to the Shadowcaster and stuff, but I don't think that's not what the issue is. Yeah, because we don't even call the PBR. Function. Yeah, so we just have alpha cutouts, so. well, I guess we can test it. Let's see. Yeah, so the alpha value should definitely affect it. Let's look at the frame debugger and see if we can tell what's going on. Okay, so it does have our object in there. We can see, yeah, my lit, forward lit. It has the alpha pre-multiply on. And also the other shader. Okay, so at least it's in the correct render queue. Do we not set the alpha right? Right there. Okay, so if I just hard code this to 0. Okay, no. I'm probably forgetting some simple flag. Yeah, so it works with alpha, which is this normal blended. I can turn, but for some reason when I turn on pre-multiply, is it because of the workflow maybe? Like if I turn this, oh, okay, it was a silly mistake of me. Okay. Yeah, so when I turn metallic all the way up, I guess the specular highlight was strong enough that it just canceled out the alpha being 0. Yeah, so sorry, we've been coding for like 3 hours straight, so start to expect a few silly bugs, but no big deal. Okay, so okay, well, I guess this is a good illustration of what it does. And this kind of makes sense because if you had fully metallic glass, I mean, you couldn't see through it, so. Okay, yeah, so that's fine. Okay, so advanced transparent effects. That's not really advanced, it's just additional. I guess this is more like blending modes. Okay. Okay, our shader has supported transparency for a while now, but there are some extra effects that the URP lit shader implements that we do not yet. These are extra blending modes which change the way the renderer blends your mesh with the colors behind it. It's they're not difficult to implement, so let's do it. We will add support for 3 additional blending modes. Additive, multiply, and pre-multiplied. Okay, I just realized how kind of confusing that those two. Yeah, because it's additive, so I would think this would be multiplicative, but it's just multiply, and then we also have pre-multiply, but oh, whatever. Is that what Unity calls them? Yeah, they do. I just realized I should probably test out all this stuff in 2021 before I go any further. Oh yeah. Visual Studio always hangs a bit when I open a C# script for the first time. Okay, so yeah, we just changed that and then the shader file. So alpha works. Multiply. I need to remember turn down the metallicity, but yeah, it works. And you can see here, even when I turn alpha to 0, you can see the highlight pretty strongly. Even when I turn metallicity to 0, that's kind of how it works. Alright, and then we have additive. And multiply. Okay. Leave it like that, I guess. Okay. Add and the bulk of the work is in the custom inspector. Add a new blend type enumeration with our 4 blend modes. To store the currently selected blend mode, we'll add another property similarly to how we handled the surface type. Let's see. So yeah, and on GUI we'll get the blend property and then set it. Get and set this new property in the onGUI function. Then we can use it in the update surface type. Let's see, read the blend type property before the second switch statement. Then if surface type is blended transparency, switch between, or let's say switch the blend type, setting the source and destination blend modes like this. I guess I should kind of explain what each of these does. Okay. Quotes here so that error will go away. Let's quickly look at each of these. Oh, hi i3, how are you doing? Okay, the alpha mode works like we're used to, blending based on the alpha value of our source pixel. Pre-multiply is a special mode which tries to imitate the way glass looks by increasing alpha in shiny areas. In this case, the PBR lighting calculation or lighting algorithm will calculate correct. Let's see. Well, okay, so let's see. We'll multiply the alpha value into the into the source color. Hence the name pre-multiply. So we don't. So set the source blend type to let's see. This is kind of how PBR works, but that's not technically what pre-multiply is. Pre-multiply is just that the alpha value's been multiplied into the color texture. So basically areas that are darker don't show as much on the final. Let's see. I guess I do need to explain this later because that's how the PBR algorithm does it, but assumes alpha has been multiplied. Okay, pre-multiply makes brighter areas stronger in the final image, as if alpha was multiplied with the RGB values, hence the name pre-multiply. In this case, the source blend type should be 1, meaning it isn't alpha isn't okay, so alpha isn't multiplied again, but the destination should still behave like normal. In PBR lighting, this effect is used to simulate glass, and Unity increases alpha where specular highlights are strong. Okay, I think that's a good way to say it. But okay, yeah, I guess that's fine. Maybe I don't know. I think I can work with that wording a bit, but okay. So additive mode is the simplest. It just adds the source color to the destination. Let's see. Okay. I guess it's not really the simplest. It's kind of the same. Kind of like the inverse of pre-multiply, actually. Is kind of the inverse of pre-multiply mode. In this mode, the source is blended based on transparent, or based on alpha, but the destination is not affected. The destination is not. In this way, the additive mode only lightens the scene and is great for particle effects like lightning and fire. Okay, finally, multiply mode is only for specialized use, but multiplies the source color with the destination. Completely replacing it. Let's see. it can be a little difficult to see the formula from these values, but if you write it out, it's a little more apparent. In this mode, the alpha value is completely ignored, right? Yeah, okay. It's a comma splice. Okay, again, I kind of want to change the wording there, but yeah, we're almost done. To support the glass effect for pre-multiply mode, we need to enable a keyword when this blend mode is enabled. Handle it like alpha clipping. Okay, so in the shader file, add the property for the blend type and add a pragma shader feature for pre-multiply mode. Okay, then in Unity, test these modes out. Okay, so I guess I'll write a little note about my mistake. Okay, so if you're be sure to play with different metallic and specular settings when testing out pre-multiply mode, as they will definitely affect it. As I said earlier, pre-multiply is great for glass, while additive and multiply modes are very useful in special effects. Test. See how you can use them in your game. I don't know, it's kind of a lame little closing line, but think of something else later. Okay, so I tested this here and here, so I can just commit these changes and move on. Okay, so blending modes. Okay, so we have 11, so this should be 12. One blending. Okay. All right. I kind of wanted to stream for 3 hours, so I got 20 more minutes. Although usually I would want to end at 1, but got started late because I had to take care of some stuff. Let me take a small break, and maybe we'll tackle a little more, but I need to kind of see what's going on. So 1 second. Oh, you're welcome, Random. I'm glad you're enjoying it. Okay, it looks like I'm good for another 20 minutes or so, like I hoped. So let's move on to the next. Okay, and this is good. Emission, this is going to be pretty simple. Yeah, because we're just basically going to add an emission texture. So I think this will be a good way to end off. The real-time lighting is actually kind of simple too. It sounds scary, but basically we're only going to add keywords. So I guess we'll just see where we get. Yeah, I've got to do all this tomorrow. It might be possible. Baked lights, there's a lot in here, so well, we'll see. Like I said, I'd like to finish the second video script by the end of the weekend, but if not, I guess it's not a huge deal. It's more important to keep the quality. Okay, so mission textures. All right, so this is pretty simple. I just committed it. So basically, emission texture is just another color that's kind of added on to the lighting. So you can use it to kind of make glowing objects. And when we add baked lighting, it really enhances the effect. But yeah, we haven't done baked yet. Do we want to do emission after baked lighting? Because a lot of emission is, well, okay, let me think. So the meta pass, yeah, I have to set emission here. I think that's why I had done it before. Yeah, because otherwise I'll have to just have this emission value be 0. I mean, I guess that's okay. I mean, I don't know. I don't think it really matters that much. We might as well just do it before. That way it'll be ready to go. Okay, yeah, what's next after? Oh yeah, then the advanced lighting and then baked lights. Okay, I think kind of my idea here is that we'd finish everything that has to do with the actual like shader properties, and then we'd start adding like lighting and stuff. So okay, I guess we'll stick with that because we should have, after emission, I think we'll have pretty much well, we'll still have occlusion, but there's no reason to add occlusion until we get baked lighting. Because I was gonna say we'll have all the properties filled out, but yeah, we'll still have this occlusion stuff. But anyway, yeah, because I can't do occlusion before because it wouldn't affect anything until we get baked lighting. So it's fine. It doesn't make a whole lot of difference. Okay, so don't know why I was adding a new line there. Oh, I never added this comment. Okay, that's going to be a little out of place now, but we'll just deal with it. Did I spell this right? Okay, it just looked wrong here. Okay, got it there. And the forward pass, we just need to sample it. Okay, I gotta get rid of the occlusion for now. Where'd this go? After the tangent space normal. And I don't think I defined the emission tint. Okay, good. No errors, that's always a good sign. Okay, so if we add our little dots and then turn up the emission tint. Oh, I forgot. Yeah, so this is actually all white. It just has an alpha channel. And the alpha is not actually used in the emission. Okay, but yeah, I kind of wanted to do the non-transparent one anyway. Let's see. I mean, I guess we can do the rainbow. This is gonna be hard to tell. It just makes it. I mean, it's gonna be kind of the same as if it was white. I guess not. Okay, so yeah, I can see it. This kind of like adds a color. It's kind of like our additive mode, but on the actual material. So the reason it washes out everything is because if you add pure white to it, it just, well, I mean, the maximum color can be 1. So if white is 111, so whatever you add to white is still white in terms of shader logic. I know you're shader focused, but have you considered looking into how to use graphics, draw mesh instance, and material property blocks in ECS yet? CodeMonkey has a video about it called 100K Sprites. I have used draw mesh instance. I can't remember if I did it in a tutorial yet. I guess I've done draw procedural, but yeah, I'm open to doing pretty much anything with graphics. So yeah, I definitely like to look into that. Actually, I'm really interested in doing like GPU skinning for like animations on the GPU, which also uses instance sprite or instance meshes. So hopefully I'll get to that some point. But yeah, so I have looked into it, but it's not. I'm not working on it at the moment, I guess. Okay. So what am I doing here? Oh yeah, I was just testing emission. Let's just try this periwinkle. Kind of funny. Why is it still red? Shouldn't it be blue? Oh, it's because this is a normal map. Yeah, okay. Yeah, so you can't really tell because Unity hides it, but the way that they encode normal maps, they're not actually this blue color. Do I have... I guess the way I could do this, let's change this to the rainbow and then just take our albedo to be neutral gray. Okay, yeah, there we go. Now I can, so you can see when I turn off the emission, you don't see the color anymore. And you can't really tell right now, but obviously when I have baked lighting on, you can move this down here and bake a light map, and then the emission color would show up on the light map, but we don't have baked lighting yet. So anyway, let's test this in 2021. Okay, so again, I'll turn this to neutral gray and set the, okay, let's turn off specular workflow, set the rainbow, and then I can turn on, okay, so there we go, got some emission colors. Are you currently trying to do a project with that draw mesh instanced? I used to work a lot with the Unity ECS, but I haven't in a while. I feel like they were kind of dragging their feet with it, but I need to look and see what new they've added. All right. Okay, so I think we're done with this. Let's start writing. So, how do I want to start this? I guess some materials. All right. Some objects like electronics or magical artifacts might have glowing parts. This is traditionally really difficult to get working efficiently, but we can get a similar look using emission textures. These textures encode a glow color to areas of your model, which the PBR algorithm will treat kind of like intrinsic lighting. They're super easy to implement. Let's see. Yeah, you're doing the messy coder jam and a production project with entities which in Unity 2020 is more stable and works okay with shader graph. Oh, that's cool. 2021-22 entity support is not working well till the end of the year, they say. Why do they break stuff? Okay. That was kind of a roller coaster because I was excited that entities were good, but then yeah, I hear you say they're broken. Yeah, that's a shame. Yeah, I feel like, I don't know, Unity is just kind of in like a transition period at the moment because they're writing a lot of new stuff, but it seems like they have a really hard time keeping everything working together. I mean, they are a huge company with a really complicated piece of software, so I guess it's kind of to be expected. But yeah, not great for us end users. Okay, let's add okay, I don't need that. Add emission texture property to your shader file. Oh yeah, should be an emission. Can tag it with the HDR attribute, which tells Unity. Oh wait, no, this is actually not true. As well as an emission tint. We can tag the tint color with the HDR attribute, which tells Unity to use the HDR color picker. If you're not familiar, high definition. Oh wait, is it high definition or high dynamic range? I guess I should look that up. Define HDR. Okay, high dynamic range. Range, which basically unbounds colors from the 0 to 1 range, letting them take higher values. On HDR greens, these colors would appear more bright. You don't need to worry about it too much, but it is a cool effect. Okay, add the new properties to the common HLSL file, then sample the emission texture in the forward lit fragment function. Emission is stored in surface data, so set the value to the RGB channels of the emission sample multiplied by the RGB channels of the emission tint. Notice the alpha is once again unused. You can fill that with data later on if you'd like. Let's see, I guess you can use that data later on if you like. Okay, and that's all you need to support emission. Not all shaders or not all materials need emission textures, so you can add an emission keyword. I guess keyword to toggle this on and off. There. Okay. There. Okay. There are trade backs to this. Is that the right word? Yeah, I think so. On one hand, you sample one less texture, but adding too many shader variants will make SRP batching less efficient. Which I think I talked about that in part 1, right? Yeah. Turns out descriptive SRP patcher. Well, if you're curious. Do I talk about how it batches shader variants? Okay. SOP batcher combines objects using the same shader variant into the same event. Blah blah. So batcher, as long as properties won't trigger a shader variant change. Okay. That's what I wanted to make sure. While I'm doing this, I should make sure that I haven't messed up the shader and that it's still compatible with the SRP batcher. Okay, good. Okay. This is up to you, but perhaps wait until you need to optimize before worrying about it. Let's see. Test it out by switching around your textures and playing with the emission tint values. Note that if emission tint is black, no emission will appear. In the future, we'll tie this in with baked lighting so emission affects objects around it. One final word. Okay, so that's it for emission. Okay, so I tested it, so let's commit this. Okay, so 13. 1 emission. Same here. Okay. Okay, so what's next? Okay, so advanced lighting. And like I said, this sounds scarier than it is. Basically, we're just going to add a bunch of keywords and kind of explain a little bit how all this works. We don't really have to change our shader at all, which is nice. I guess we will for shadows, but that's about it, I think. All right, but I think, yeah, I better sign off for today. I need to go. I'm starting to get a little hungry, so. But yeah, thanks everybody for coming by, and thanks so random for chatting. And I hope your project goes well. Yeah, I'd really like to work with that at some point, so I'll keep you in mind when I get to it. But yeah, so I'll be back tomorrow. I'd like to start around 10 Eastern, but I mean, it is my weekend, so we'll see what comes up. But yeah, we'll work more on this, and hopefully we can finish up at least these real-time and baked lights. That would be nice. But yeah, have a great day, and I'll see you tomorrow. I'll put some links in the chat if you enjoyed the stream and you'd like to connect with me. I do have a lot of YouTube tutorials, so if you're interested in Unity shaders, check me out there. Ooh, don't know what that $ is in that message. It looks like they changed their code or something, but okay, so I'll see you tomorrow, and have a great weekend. Bye-bye. All right, hey everybody. I hope you've all had a nice Saturday. Yeah, mine was pretty good. We just kind of the normal Saturday for me, usually dream, and then well, I have like a DM for a D&D game almost every Saturday night, so most of the afternoon is spent preparing for that, but it's always fun. But yeah, so today we're going to continue on my URP shader tutorial. And I think what we're going to try to finish. So I've been working, so this tutorial is really long, and it's kind of just like explaining how to write a fully featured code shader in URP. And I've kind of broken it up into 3 videos. The first one is more about like the introduction to get just a standard shader. And the second one is trying to add on all the features from the URP lit shader. So like physically based lighting and metallicity, decals, all that. And then the third video is about customizing it to make it your own we'll talk about custom lighting and then some optimizations and other features. But so we just did a mission. So today I'd like to at least finish, excuse me, at least finish these 2 sections. Yeah, which the advanced lighting sounds scary, but we're mostly just going to be adding keywords, so I don't think it'll be too bad. Baked lights is a pretty big thing, so I feel like this will take up the bulk of the time today. And then if we have time, I'd love to be able to finish the rest of the video 2 features, because all these are relatively simple, but I don't know, we'll see. Okay, so yeah, so we've got real-time lighting. So I guess, let's see. So what I have to add, so additional lights and shadows is mostly a keyword, except for point lights. We've got to change the shadow caster slightly. Light cookies and light layers, I think, are keywords only. And then screen space shadows we will have to change a little bit of the actual shader because we have to sample the or we have to store the screen space position and the vertex function. Okay, so let's see here. I think first what I'll do is add support for additional lights and shadows, and then maybe we'll do each of these one by one because they're kind of separate. Okay, so let's do that first. Okay, so adding additional lights is always a bit of a pain because there's a lot more that you have to test. Okay, so it looks like I already committed the emission changes, so we're good there. Okay, so first I'm gonna remove the emission from shader, and okay, I guess we'll keep it neutral. And then this other one, let's just make it. Well, I mean, the transparency shouldn't matter. I was gonna say let's just make it opaque, but I guess having it transparent might be useful. Okay, so first thing, to support additional lights, it's really simple. I think all we have to do is add. Well, we do have like vertex lighting. Okay. I don't think I even have that in my outline. Okay, so let's do additional pixel lights. Alright. Light shadows and point light shadows. Okay, I mean, they're kind of point lights are additional lights, but we have to do a little bit. Of extra logic for them, and then vertex lighting. Okay. And then the rest of these I don't really know if the order matters, but okay. So let's just add in more lights first, and then we'll worry about the shadows. So I think all I have to do, I'm going to keep on clicking the wrong thing because Windows, I know you can't see my taskbar, but I have 3 Visual Studio instances opened, one for each Unity project, and Unity, our Windows has like ordered them in a way that I'm not used to. And I don't think you can change the order of windows that are grouped together, but anyway, I'll make do. Okay, so to add in additional lights, I think, yeah, so all I have to do is add in this multi-compile with additional lights. So we won't support vertex lights yet. So let's do that. Make sure it's in the same order. And take out the vertex lighting. Okay, that should be all I have to do. So let's add in some more lights and check. Didn't want directional light. Spotlight. Okay, so it looks like it is working. So yeah, of course, no shadows yet. Let's make it red so it'll be really obvious and just increase the intensity. Okay, well, I guess maybe purple. I think it's affecting the transparent one, but it's kind of hard to tell. Let's... Okay, yeah, you can see the purple highlight on it. And if we turn that off, yeah, it's definitely affecting it, so that's good. Okay, and then let's make a spotlight. Or I already have a spotlight, let's make a point light. Okay, let's place it something like that. And maybe make it green. Okay, yeah, so that's definitely affecting both of them. But again, yeah, no shadows. And if I even put soft shadows, yeah, I'd say, yeah, point light shadows aren't even supported in 2020. But yeah, even if I put soft light here, it doesn't show up because we don't support it yet. Okay, so is that all I have? I think that's all I have to do for additional lights. Okay, let's test it out in the 2021 version. Okay, let's just copy and paste. And we'll add a spotlight. Where is it? Oh, here. Okay. Okay, so let's move it and place it kind of above the two custom lit objects like I did before. We'll make it purple, increase the intensity. Okay, so that definitely affected them because we can turn it off. And then we'll make a point light here. Let's do it on the other side. Yellow, or I think it was green before. All right, there we go. Okay, so all good. All right, so let's write a little bit about that, and then we'll move on to shadows. Okay, so one other thing. I guess I need to make sure that the additional lights are per pixel. Should write something about that. Okay, so far we've only worked with the main directional light, but additional lights are important to set up the mood of most games. In this section, we'll add several features for supporting let's see, additional lights and more advanced real-time lighting. Well, I don't think I'll say that, but I was gonna say, like, well, if you don't need this stuff, you can leave it out for faster shading, but I mean, I guess that's kind of obvious. First, let's add support for Unity's spot and point lights. These can be shaded per pixel or per vertex, but let's implement the per pixel version first. Make sure this setting is enabled in your URP settings asset. It's very simple to add additional light support when using URPs built in, or I don't want to say built in because that's kind of confusing. URPs provided lighting algorithms. We simply need to add a keyword multi-compile. Okay, I think I've already explained that, so I guess I don't have to say anything else. Afterwards, you should be able to use any combination of point and spotlights up to the limit in the settings asset, of course. Okay. Be sure to increase their intensity to when testing to make their effects obvious. Okay. Yeah, so then we'll go on to shadows. So let's go ahead and commit the changes so far. So additional lights. Okay, so I think we're on 13 or 14. So 14.1, let's say add lights. And then in one, oh, I've already in assets. Oh, you know what? I should actually be committing from here. I guess not that it really matters that much. Additional lights. Okay. All right. So now we want to add additional shadows. Which there's a little bit we have to do extra besides, well, the main thing is we have to add a keyword for additional light shadows. And then in the shadow caster, we have to add this keyword. Which, you know, actually won't even do anything in 2020 because point light shadows aren't supported, but I want to have a unified shader for both versions. Okay, so then in the shadow caster, we have to change a little bit. I forget. Let's take a look. I think mostly I just need to change this get shadow caster position. Yeah, because we have to get the light position. And then, yeah, if it's a point light shadow, instead of just using the light's direction for the shadow bias, we have to take or we have to find the direction of this position from the light. Okay. I'm just checking to see. I think this is it. Okay, well, this is, yeah, I have instancing stuff. That's the only other difference. Okay, so that should be all we have to do. So I need to turn on additional light shadows here. And then I have to turn on additional light shadows here. Okay, and there we got shadows. So obviously this doesn't cast a shadow because it's transparent, but this one does. And then we can move it back and forth. But of course, the point light, if I put on soft shadows, nothing happens because it's not supported. Okay, so let's add this to the 2021 version. we go. We got shadows. Okay, and let me think. I've got shadows here as well. All right. Yeah, so it was relatively simple. Okay. All right. But these new lights do not cast shadows. We can add, although point, light, shadow, let's see. We can add support for that, although keep in mind URP only supports point, light, shadows. Oops. After, oh gosh, 2020.1, and there's nothing we can do to fix that in 2020.3, short of rewriting the rendering engine. Regardless, start by adding this keyword, multi-compile, which enables additional shadows in the PBR rendering algorithm. Okay. Remember shadow biases. To have them work correctly for point, light, shadows, we need to add some logic to the shadow caster. First, add this multi-compile to the shadow caster pass, but only in versions 20.1 and later. Then in the HLSL file, okay, let's make this a new paragraph. Okay. The problem is right now the bias is only offset by the light's direction. Point lights don't have a direction, so we need to calculate this based on the light's position. URP provides this variable containing that. So if we're rendering shadows for a point light, we can calculate the light direction like this. Okay, and then of course I'll have this section active. All right. this way you won't get as many shadow artifacts from point lights. Okay, so back in Unity, turn on additional light shadows in your URP settings asset. Oh, also, well, okay, I was going to say we should say that we need to have shadows enabled on the camera, but I forgot. Of course, we already have main light shadows, so yeah, that's okay. Then turn on soft. Oh, I guess it doesn't matter. Turn on shadows for your spot lights and point lights if you're working in a version that supports that. I won't do on a test. When I said soft lights, I should probably make sure that hard shadows work as well, which they do. Okay, so we've done that. Next, okay, so vertex lighting. If you're working with weaker, I don't know, I don't really like to say weak, I guess lighter hardware, like mobile platform, real-time additional, or let's see, real-time lighting can be really slow. One way to improve this is to only calculate additional lights for each vertex and then interpolate between these the lighting values. This is called a vertex lighting, and you can enable it in your URP settings asset. Vertex lighting. Okay, that's fine. To add support in our shader. I mean, I guess I should actually write this. Okay, let's go ahead. Just want to make sure the scenes are saved. Let's commit these changes for shadows. Okay, so I think it was 14.1 before, so it should be 14.2. Okay. So to add vertex lights, I guess we first need to add back that keyword. So additional lights vertex. Oops. I think for some reason it was ordered this way. Okay, and then in our forward lit pass, we have to add some more stuff here, I'm pretty sure. So basically we have to pass the vertex lighting through the shader. Yeah, we have this fog coordinate and vertex lighting. Okay, so this... Let's try this. Okay, so I'm pausing because we're not doing light maps yet, and this is text chord 4. But I kind of want to build my tutorial so it matches this shader. So the vertex lighting should be text chord 5. Don't know if it will matter if I skip over 4, but I guess we'll just see. If it does, I mean, we could just change the text chord later, but I think that just adds in. Okay, and yeah, we don't have fog yet, which is also kind of confusing, but okay, so we'll do that. Okay, and then the vertex function, we need to calculate the vertex lighting, which all we have to do that is call this function. And I could just do output dot vertex lighting. Okay, let's see. Any errors so far? No. And then in the fragment function, I think all I have to do is pass the vertex lighting to the lighting input. After... Oh, this is custom lighting. Okay. So after the shadow coordinate. Okay, so no bugs. So all I should have to do is turn on per vertex. Okay, so yeah, shadows turn off when there's a vertex light. But yeah, you can see these artifacts are from it. All it does is calculates lights for each vertex on the mesh. I guess I can make it really obvious if I turn the wireframe on. And then it interpolates the lighting between the triangles. And so this way it only has to calculate it a few times instead of for every pixel, which can speed things up. And yeah, you can see when the light's this far away, you don't really notice the artifacts. Is it working for point lights too? Okay, yeah. I don't... Oh, that's interesting. So did transparent objects not get vertex lighting? If I change it to opaque. Oh, is it just because that area is black? Maybe? Okay, yeah. I was gonna say. So if I change this to white. Yeah, so that is just that black area is kind of making it hard to see the lighting, but okay, there we go. Just want to get back to how it was before. Okay. So let's add this to the other shader. Oop. Then here, I'll just turn on per vertex. Again, let's all right. Yeah, it's still working. It's really easy to tell on the spotlights. I guess I don't want the wireframe mode on. Okay, so we need to first add another keyword to the additional lights pragma line. Remember, if there are multiple keywords, Unity, I guess, on one multi-compile command, Unity will generate a shader variant with each keyword enabled, one at a time, and then the empty or the underscore also generates a variant with none of the keywords enabled. Okay, so then in the forward lit pass HLSL file, we need to calculate the lighting per vertex, but then pass it to the fragment function to calculate the final pixel color. Add a vertex lighting interpolator. I'm skipping text chord 4 for now because it's traditionally used for something we'll get to later. Okay, so then in the vertex function, call vertex lighting, passing the world space position and normal. Then in the fragment function, set the vertex lighting field in the lighting input data to the interpolated value. Okay, just making sure I'm not forgetting something. Okay. Back in Unity, test this out. Make sure vertex lighting is enabled in your URP settings asset. You may have to get your lights very close to your objects before the effect becomes obvious. This technique was used in many older 3D games, so it can be nice for if you're going for that style. But for now, turn back on pixel lights and let's continue adding features. Okay, so next up, I think, is light cookies. Light cookies are really cool, I think. Basically, it lets you add a texture to a light, and the texture determines like how strong the light is per pixel. So you can use it. I would use it like if the sun is shining through like leaves or something, you can get that kind of cool effect. So it's only available in 2021.2, but I think all we have to do it or to add support is add a keyword, I'm pretty sure. All right, so this is vertex lighting. So 14.3 vertex. All right, so now let's add that keyword real quick. Let's just get this whole thing and then I'll delete what we don't need. That goes after Shadow Soft. Okay, so I mean, it'll work in this version, but we can't test because there's no light cookies in 2020.3. Okay, so let's add a light cookie to the sun first off. Okay, I guess you can't do a light cookie on the sun. Really? Oh, here. Okay, I don't know why I just didn't see it at first. Okay, so our dots should work. Okay, so it seems like it actually uses the red channel and not the alpha channel. Or I guess it just uses the color and not the what's it called? Yeah, so it doesn't use the alpha at all, which is fine. So you can see it's pretty cool. Yeah, the color of the light affects it as well. And you can change the scaling of it. I guess Y doesn't affect it. And then like if we rotate the light, it also keeps orientation. Okay, so yeah, it works for the main light. Let's try it for the other ones. Also works here, looks like. Okay, I was saying, how come there's this weird color, but it's because our light is purple. Okay, let's change that back. Make it white. Try to see. Okay, yeah, there we go. It is. It is on there. It's almost like a decal, but it's like on the actual light. Okay. And yeah, it works on the default materials as well. I guess, yeah, the ground is a default material, so. Yeah, I was just curious. I wanted to make sure that shadows cast onto the material work, which they do. Oh, it's because this is transparent still. Oh, yeah, this is kind of weird. Let's not do that actually. So this will be the ground. And the ground should be opaque. Yeah, let's turn off the normal map. Okay. Yeah, so that's all we have to do for light cookies. What about point lights? Okay, it does support light cookie, but I don't have a cube map to test with. Okay. Maybe we can just make a cube map. Completely forgot about this kind of thing. But yeah, I need to test this before I move on for sure. Let's see. Unity create cube map. Doesn't. I guess I should make sure that this actually is looking for a cube map. Yeah. Yeah, I thought I could create a cube map by just. Yes, this is what I was looking for. Assets create legacy cube map. Okay. So cube map. And I'll just put the rainbow on every side. Okay, say this is a rainbow cube map. And then point light, give it this. And turn it white. Okay, so it looks like it's working. Let's turn off the spotlight. And again, this one is actually transparent. I guess I should make it a little bit more transparent so it's obvious why it doesn't cast a shadow. Okay. Yeah, so now we've tested it on all the different lights, so we should be good. Okay, light cookies are a cool feature, which allow you to attach textures to lights. These act as if the light shone through the textures, coloring the light as it does. Okay, well, I might change that wording, but it's simple to support, but this is another 2020.2 only feature. In your shader file, add this keyword, pragma, surrounded by the version checking block. In Unity, test this out by attaching textures to your main light, spotlight, and point light. Point lights need a cube map, so if you don't have one handy, you can create one using the legacy cube map asset. It's pretty cool, right? Okay, so that's about it for light cookies. I like light cookies, but I think they're kind of heavy, so they're not super used. Maybe they're more used in like HDRP, but I don't know. I think they're really cool. Plus, I like the name. Always makes me hungry. Okay, so 14.3. Oh, wait, did I already do 3 or... Yeah, so I already did 3, so this is 14.4. Okay, So first I'm gonna just remove the cookies. Change these back to the colors we had before. All right. So next we have light layers. This is another 2020.2 thing, and it lets you like add lights to layers so only certain lights affect certain objects. Another 2020.2 or 2021.2. Oh, yeah, I did the wrong number here. Feature is light layers. This allows you to add lights to groupings which only affect certain objects. Support is again super simple. Just add another keyword in Unity, test it out. This is useful to highlight certain objects in your game. Okay, so like for pickups you could have are affected by an extra light or something. Let's see. So for this, yeah, we just have to add this pragma. No errors. Okay, so let me remember. I think the culling mask? No. Oh yeah, so here's the light layers. So default. Oh, let's just call this a special test. Let's see, where do you add the light layer? Okay, so the rendering layer mask is here. But where do I add lights to that? Okay, let's look this up real quick. Oh, yeah, it's hidden. Okay. Oh, I think I had to turn them on here. So turn on light layers. Okay, and then you can see them here. Okay, so let's turn the sun, well no, let's turn the spotlight to special test. So now this is in the special test layer and none of these are, so they're not affected. So then if I put this in the special test layer, then you can see it's affected. And then if I turn off 0, then it's only affected by the point light. Is that right? It seems like... Oh, maybe do I still have... Okay, I still have emission on. Okay, I was gonna say... Yeah, it was too bright. But yeah, so here... Just... Yeah, so you can see that it's not affected by this light. I guess it's still... Oh no, it's not even casting a shadow. So if I turn this on... Yeah, so then it starts to cast shadows again, and it receives light from the sun and the purple. And if I turn that off, then it doesn't receive the green light. I guess let's turn back on how it was, just to save that for this test mode. Okay, wait, so let's write that up real quick. You test it out. First, you'll need to enable light layers by showing hidden settings in your URP asset, and then enabling light layers. Then you'll see the drop down in all lights to assign them a layer. You can switch you can name layers from the URP additional settings asset and change objects layers from their renderer component. This system is useful to highlight certain objects in your game or filter. I guess you could also use it for optimization. Okay. Okay, and finally we have screen space shadows. Okay. Screen space shadows, how it works is that after the renderer renders all the different shadow maps, there's an additional pass where it combines them all onto one texture, and then your shaders only have to sample that single texture to calculate shadows. So that can be more efficient if you have a lot of lights. But let's take a look real quick. To make sure that, because there's a couple different implementations, but screen space shadows render feature calculates screen space shadows for opaque objects affected by the main directional light. Oh, okay, so it only does the main light. If it requires an additional render target, this increases the amount of memory your application requires, but if your project uses forward rendering, screen space shadows can benefit the runtime resource intensity because you use screen space shadows. URP doesn't need to access the cascade shadow maps multiple times. So I guess it's kind of like what I said, but they don't go like the additional mile by also adding additional lights to the texture. Okay. The depth texture invokes a depth prepass before it draws opaque objects. Oh, so this might not work actually, because we haven't implemented the depth pass yet. Okay, so I'm glad I read this, yeah. That makes sense. So we haven't implemented the depth pass yet for our shaders, so I don't think our shaders will actually appear in this render pass. Okay, so in that case, we won't do screen space shadows yet. This will go after we add the depth pass. Which is fine because the depth pass, I really hadn't had an example of how it's used because it's mostly for like post-processing effects, which is kind of outside the scope of this tutorial. But now since we have to have it for screen space shadows, we can talk about it then. Okay, so that means we're done with this section. Okay, so now the fun part, baked lighting. I mean, baked lighting is fun, but I just know this section is going to be big because we have a lot to cover. Okay, but before I get ahead of myself, let's save. Or did I already? No, I didn't commit yet. So all I did was light layers. So and it's 14.5. Okay. Let's look and see. So baked lighting. Okay, so the main thing is we have a meta pass. Then we've got to talk about how to get light maps to work. Then light probes, reflection probes, blending, box production, and then we have occlusion, and then there's some visualization testing. Oh. I almost want to break this up. Because, like, the reflection probes we could almost do separately. But, I mean, they're also baked, which is kind of why I put it in here. It doesn't really matter, I guess, if it's in its own section or not. Okay, so what order should I do this in? So I think, I'm not sure if I can get light maps without a meta pass. That would be nice. Okay, so let's see here. Oops. So maybe we can do light maps first with okay, so the subtractive lighting is this keyword basically, but I need to explain how it works. Shadow masks, okay. Dynamic light maps. I mean, and then after this, I'm just not sure when I have to do the meta pass, I guess, because I don't know what the meta pass does. Is it tells the light mapper like information about your object. I'm not sure if I have to have one. Like if I don't have one, will I not get light map EVs? I guess we can test it. Okay, so let's create a ground material for this, like I did before. Okay, that's fine. All right, so we want to set this. To static. And then I should add a couple baked lights. Um, all right, so let's go ahead and bake this. We'll use the GPU mode. It seems to go faster. Okay, so yeah, I'm gonna bake lighting, so apologies if we get some stuttering in OBS. But usually it's not too bad, so. Let me see. Set this to static. Baked. Okay, just making sure. Let's see the progress. I'm gonna take a little bit. Usually the first bake takes a... Oh, that actually was pretty quick. Okay, so yeah, we don't see anything because our shader doesn't support baked lights. However, what I want to see is if the light map... Okay, so it did actually add light map UVs for our object, even though we don't have a meta pass, which is what I wanted to see. But I guess the question is, when do I want to add the meta pass? Because that lets emission affect light maps. Maybe before, well, the subtractive mode we need to do pretty quick. But maybe before I do like the shadow masks and the dynamic light maps, we'll do meta pass, and this will have a baked emission because there's a couple tricky things about that. And then we'll do occlusion, yeah. Or maybe even occlusion should go first. So yeah, we'll have with the texture. Okay. What else? Light probes. And then yeah, the reflection probes. And then visualization. Okay, I mean, this could basically be a subsection of it, but I don't know. I don't think it really matters. For a subtractive mode, this is basically just yeah, the directional light. Yeah, it's basically just supports this mixed mode, which usually looks a little better. Okay, well anyway, let's add support for light maps. Okay, and we're not going to do light probes yet, so it'll actually... Okay, that's a good point. I think it'll be fine. Actually, I don't know if this will even work without light probes, because the way the URP shaders are built is if you don't have light maps, it expects you to have light probes. But anyway, we'll see if I can get it to work. I'd rather not have to explain both at the same time, but if I do, I guess so be it. Okay, so we want light map on. Forget what each of these keywords do specifically. Let me see if I can find out real quick. Oh, this is the core shader library. I want the URP. Oh, okay, so if light map shadow mixing is on, then it defines this mixed lighting subtractive mode. Okay, is it used anywhere else in here? Let's just check current document. No. So it turns on this mixed lighting subtractive. Okay, but interestingly, this doesn't work if the shadow mask mode is on, which I usually use anyway. Okay, mixed lights provide baked direct and indirect lighting for static objects. Dynamic objects receive real-time direct lighting and cast shadows on static objects. Mixed lights provide real-time direct lighting. Indirect lighting gets baked into the light maps and light probes. Shadow mask and light probe occlusion get generated for baked shadows. Okay, so in shadow mask mode, the real-time lights are just real-time. Subtractive mode, mixed lights provide baked, direct, and indirect lighting for static objects. Dynamic objects receive real-time direct lighting and cast shadows on static objects using the main directional light. Okay, so in subtractive mode, our static objects don't receive real-time lights, it seems like. I guess we can test this out. The baked and direct mixed lights provide real-time direct lighting, while indirect light is baked into light maps and light probes. Okay, so in this one, let me make sure I'm understanding all this. Unity, light map, modes. Okay, that's not actually what I was looking for. I'm not going to go into light mapping too much in this tutorial because it's kind of outside the scope. But since we are going to be supporting these different types, I want to make sure I understand exactly what's different between them. Okay. Okay, so they each have their own light. So in baked and direct mode, shared by all mixed lights in the scene. To set mixed lighting to bake and direct, open the lighting window, blah, blah, blah. For lights that are set to baked and direct mode, Unity only precompiles indirect lighting and does not carry out shadow precomputation. Shadows are fully real-time within the shadow distance. In other words, baked and direct lights behave like real-time lights with additional indirect lighting, but with no shadows beyond the shadow distance. Okay, a good example when baked and direct mode might be useful is if you're building an indoor shooter or environment or adventure game set in rooms connected with corridors. The viewing distance is limited, so everything that is visible should usually fit within the shadow distance. Okay. Provides the same visual effect as real-time lighting. It provides real-time shadows for all combinations of static and dynamic game objects. And then indirect lighting. It has higher performance requirements relative to mixed light modes because it renders shadow casting static game objects onto shadow maps. Shadows not rendered beyond the shadow distance. Okay. Shadow mask mode is a lighting mode shared by all blah 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 blah. Shadow mask is a texture that shares the same UV layout and resolution with corresponding light map. It stores occlusion information for up to 4 lights per texel because textures are limited to 4 channels on current GPUs. Unity pre-computes shadows cast from static game objects onto other static game objects and stores them in a separate shadow mask texture for up to 4 overlapping lights. If more than 4 lights overlap, any additional lights fall back to baked lighting. Which of the lights fall back is determined by baking system and stays consistent. Light probes, blah, blah. Light overlapping is computed independently of shadows receiving objects, so an object can get the influence of 10 different mixed lights, all from the same shadow mask probe channel, as long as those light bounding volumes don't overlap at any point. Okay, yeah, and then if you have distance mode, it only uses this beyond a certain distance. Okay. So a dynamic caster with a dynamic receiver uses the shadow map. A dynamic receiver with a static caster uses light probes. Static receiver uses shadow map. Shadow mask, okay. So yeah, basically the shadow mask is baked shadows, so it's static objects. For the same visual effect as real-time lighting, provides real-time shadows from dynamic objects. One texture operation. Only provides low-resolution shadows from static game objects onto dynamic game objects via light probes, which is probably the biggest disadvantage, because unless you're really smart with your light probes, it's obvious. Okay. And then subtractive mode. Okay. It's the only mixed lighting mode that bakes direct lighting into the light map and discards the information that Unity uses to composite dynamic and static shadows in other mixed lighting modes. Because the light is already baked into the light map, Unity cannot perform any direct lighting calculations at runtime. In subtractive mode, static game objects do not receive or do not show any specular or glossy highlights at all from mixed lights. They also cannot receive any shadows from dynamic game objects except for the main directional light. Dynamic game objects receive real-time lighting and support glossy reflections. However, they can only receive shadows from static game objects via light probes. Okay. Subtractive mode, the main directional light, which is usually the sun, is only light source which casts real-time shadows from dynamic objects onto static game objects. Shadows cast from static game objects onto other static game objects are baked into the light map, even for the main light, so Unity cannot guarantee correct composition of baked and real-time shadows. Subtractive mode, therefore, has a real-time shadow color field. Unity uses this color and the shadow to composite real-time shadows with baked shadows. To do this, it reduces the effect of the light map in areas shadowed by dynamic game objects because there is no correct value that the engine can predetermine. Choosing a value that works for any given scene is down to your own artistic choice. A good example of when subtractive light mode is useful is when you're building cel-shaded with outside levels and very few dynamic game objects. Okay, so dynamic caster onto a dynamic receiver uses the shadow map. Light probes again. The main light shadow map. And then shadows are just baked into the light map. Okay. So I'm just trying to decide how much do I want to talk about this in the tutorial. And also, when do I want to... Okay, so this makes me think... Okay, let's see how much Like maybe if I can do, excuse me, the subtractive mode afterwards. Okay, so we had. Okay, so this is for subtractive shadow mode, and then the Dur light map combined. Let's see what this one does. Oh, okay, so this is when you have the directional light map. Okay, so I guess since we are going to talk about that, I guess we should see. There are 2 directional modes available for light maps. To set directional mode for a light map, blah blah blah, open it. Directional light maps store more information about the lighting environment than non-directional light maps. Shaders can use that extra data about incoming lights to better calculate outgoing light, which is how materials appear on the screen. This happens at the cost of increased texture memory usage at shading time. So, okay, so the non-directional, I guess, is flat diffuse. It just uses a single light map storing information about how much light the surface emits, assuming it's purely diffuse. Objects lit this way will appear flat. Yeah, so normal maps won't be used, and diffuse, even if the material is specular, but otherwise will be lit correctly. These barrels are using baked light maps. The only detail information comes from the reflection probe and an occlusion map. Okay, so... Okay, so this one's directional, I guess. This mode adds a secondary light map which stores incoming dominant light direction and a factor proportional to how much light the first light map is the result. How much light in the first light map is the result of light coming along the dominant direction. The rest is then assumed to come uniformly from the entire hemisphere. That information allows the material to be normal mapped, but it will still appear purely diffuse. Oh, I see. So, okay, I didn't realize Unity had that support. All right. Okay, but we don't really have to worry about it. I guess. Let's see. So if we don't have that keyword, what should we do? I guess the simplest way would be, so if I just have shadow mask mode and non-directional mode, I guess we'll have to see what Unity will support. Because I want to, you know, kind of show how all these things affect each other. And then set this to static. Okay, so if I have the lighting mode to shadow mask, and then non-directional, and I generate lighting, how does it look with nothing? Okay, so it still shows the shadow. Oh yeah, because the shadows, our mixed lights are all real time in shadow mask mode. So if I did this shadow, okay, I was gonna say the shadow would disappear because I thought since these were both static, they would not receive, they wouldn't get any real-time lighting. But it doesn't look like the shadow was even in there. Oh wait, okay. Yeah, big indirect is actually the highest resolution, or the highest fidelity kind, I guess. Okay, so if I do subtractive mode, and then it just looks wrong. That's because we don't have the baked lighting working correctly. Okay, so I guess I should just do baked and direct first, and then non-directional, and then we'll add support for the rest of the features. Okay, and there's no baked directionality at this point because I turned it off. But if I turn on directional mode, we should get it. Yeah. So this is showing like the direction to the main light, or the strongest light. So you can see it's kind of green because it's the main light, but then when it gets close to the two baked point lights, it changes color because I assume it's pointing towards those point lights. Okay, but anyways, let's turn off that because we won't support that just yet. Okay. Yeah, you can see there's a ton you can get into with baked lights, and I had forgotten some of this. Okay, so I think all I have to do really is just do this, compile, or pragma. Just trying to so it goes below, like right here. Okay, and then of course we have to do a lot to the forward pass, and I'm hoping that this will work without spherical harmonics. But let's see. And spherical harmonics is how Unity implements light probes. Okay, so like right now they have this declare light map or spherical harmonics data, which they implement with a macro. But I don't want to use a macro right now, so I think maybe this, if I could just do float 2, static light map, UV is text board 4. And then in the vertex function, so we have this output light map UV. Okay, well maybe this will work fine because it uses like some macro trickery to work. So yeah, if light map on is not. Okay, so I guess what I can do, let's see. So if not defined light map on. Okay. And then down here. Okay, so I use this calculate GI function, but I don't have to get that complicated yet. I guess we can. It's not that big of a deal. Okay. Where did I put it? Above apply normal map. Okay, so we'll delete this. And then we'll just say if defined light map on. Actually, I don't even know if it matters. Well, let's see. So we'll want to just return the macro. And then I hope this will work if I just return 0. Again, I was using. Oh no, this is correct. So it was after vertex lighting. And actually, I don't even need to pass the normal yet, because okay, I mean, if this doesn't work, I can actually just call sample lightmap directly. Okay, yeah, it doesn't. Invalid subscript static lightmap UV. No matching one parameter function. Okay, so just trying to see where it defines sample GI. Does it not do it in this file? Oh, here it is. So if lightmap on, so it technically should work, because it doesn't even. So the way the macro works is that if lightmap on is not defined, then it would call this version, but they would replace this string with this string, which doesn't even have the lightmap name, so it's okay if it's not defined. So we'd basically just be calling sample spherical harmonics 0, 0. I mean, I guess I could just call sample lightmap. And then we'll just pass 0. Okay, but then I have to do the macro myself. I guess this is okay. So if that def lightmap on, then we'll do this. If it's not defined, then we'll just return 0. Okay, does that work? No. Valid subscript static lightmap UV. Did I name it something wrong? Oh. Yeah, that should be if defined, not if not defined. No matching one parameter function. Oh yeah, because it still wants the normal. Okay, so it's not working still because the ground texture does not have any light maps. Okay, let me just bake this again to make sure. So we have baked indirect, non-directional. Okay, so it should be working. I mean, I guess unless the meta pass is what's messing it up. Does it need, maybe it needs the normal even just if it's non-directional mode. If that's the case, maybe we can add this back in. No, that wasn't it. maybe just turn it down. Maybe the sun was too strong. I guess let's make sure that the light map on keyword is actually on. Maybe that's the problem. Maybe Unity doesn't turn it on if you don't have a meta pass or something. So it would be frame debugger. Okay, so the light map on is here. This is for okay. Yeah, the frame debugger is a little buggy, but because it doesn't work perfectly for URP in 20.3 because when you click on these, it should hide the objects that haven't been drawn yet. But yeah, so here it's drawing our light map on objects, which I think is the sphere and the ground, and then it's drawing the default lit shader, and then it's drawing our non-static objects. And here the light map on keyword is defined, so it's using that correct what's it called, shader variant. Okay, so I guess what I can do maybe is to make sure it's not like overwriting it or something. Let's just return the baked GI. This is a good debugging thing. Oh, yeah, this should be float 4. Okay, so the baked GI is working. It's just not being added somewhere in the lighting algorithm. Oh, because occlusion is 0. I didn't want to have to talk about occlusion yet, but I guess I'm forced to. So we just set it to 1 for now. Yeah. Yeah, that was it. So now we can see the yellow and blue baked lights. Let's turn off these extra lights just to make this more obvious. And you can see that the static or the dynamic game objects are not receiving any baked lighting because the shadow is still so dark. Okay, well that's fine. I guess we can just, we don't have to add an occlusion map yet, although I guess we could add one right here. Maybe we should, since we're already talking about it. Oh, well I already was going to do it right after Lightmaps. Okay, well that makes it easy. Okay, well let's stop here, and then we'll add the occlusion texture. Alright, so I'm glad I found, so remember I have to have baked indirect mode and non-directional. And we'll go from there. Okay. So real-time lighting is expensive, but it's expensive and let's see, so I mean it doesn't unless you have ray tracing, does not always act completely realistic. To help with both of these problems, Unity has an extensive baked lighting feature set, which aims to pre-calculate as much lighting data as possible and store it in textures and other data structures, which shaders can easily access. To support all the various baked lighting features is a task, but I'll help walk you through it. Let's get started with the bare necessities, a light map. This is a texture assigned to static or non-moving objects. Which contains light values from static lights. Okay, let's see. As I mentioned in the intro, baked lighting, this tutorial will not explain all aspects of baked lighting, but rather will show you how to implement them in your an HLSL shader. There's a lot to cover, so let's get started with the basics. Lightmaps. No, to cover. So lightmaps are textures containing light data generated by Unity, which static or non-moving objects can sample. Lightmaps have their own UVs stored in the text-cord1 stream of the mesh. Okay. To begin support, add a multi-compile to your forward light pass, which will be enabled for static objects that have light maps. Light maps have their own UVs stored in the text cord one stream of the mesh. So add a field to the attributes struct. We'll also need to pass this to the fragment function. This will use the text cord 4 register that we saved, that we left open from before, to save some cycles. Only set this field if light map on is enabled. Okay, so in the vertex function, use this macro to calculate the scaled light map UV for this vertex and store it in the output. Okay. The macro will. Okay, so that's kind of interesting, actually. Oh, okay. I was getting a little confused. I thought. Yeah, I don't actually assign it, so this macro will just delete itself if light map on isn't enabled. Will do nothing if light map on is disabled. So there's no need to wrap it in an if-def command. Okay, so in the fragment function, we'll we pass all baked lighting to the lighting algorithm through a baked GI field. Let's calculate this value in its own function. Oh yeah, do I need the normal? Let's just set this to 0. I don't think so. Okay. Because yeah, it's only for directional light maps. Which actually, now that I think about it, I should test all this stuff in the other version to make sure. Because Unity did significantly change light maps. Okay, let's turn off metallicity. Okay, let's just set up something similar. Okay, so this should be static. Make another sphere. Set over here to test shadows. And then let's add baked light 1. Okay, and then I want to pick indirect, non-directional. Also, I just realized I shouldn't call them static lights. I should call them... Oh, okay. I don't even mention them, so never mind. Okay, so yeah, it works. If these are static. Oh, okay, let's get rid of the light map stuff, or the light layer stuff. And I think I'll disable the real-time lights to make things clear. So again, yeah, the real-time objects look pretty dark because they don't receive any global illumination right now, because we only have light maps. Okay, passing the entire input structure. If light map on is defined, call this function from URP's lighting library to calculate or to sample the light map at this UV. The second, or let's see, ignore the second argument for now. With this, we've calculated the baked lighting, but it won't display just yet. That's because another value, the occlusion, controls how much baked lighting affects a surface. For now, set it to 1 in the surface data struct. Back in the scene editor, create a ground mesh using your lit shader if you haven't already, and tag the object as static. Create another sphere above it using your shader, and also tag it as static. This will help test baked shadows later. Open the lighting menu and create a lighting settings object. For now, we want the simplest light maps possible. So set the lighting mode to baked indirect and the light map direction mode to non-directional. Okay, did say that correctly. So the lighting mode to baked indirect, light mapper directional mode to non-directional. You can use either the progressive CPU or GPU light mapper, whatever is faster and more stable for your system. Okay, so bake a light map. Oh yeah, so actually, I need to next create a couple point lights of various colors and set them to baked mode. Turn off the other additional lights for now. Okay. So bake a light map. You should see the lights appear on your static game objects, but not your dynamic ones. Additionally, if you move the baked lights, their lighting won't change unless you bake again. Okay. So I think that's everything. Alright, so next I guess we'll do occlusion. Let's save these scenes. Okay, so this is 15.1 light maps. Okay, so next, I guess we'll talk about occlusion. And all I really have to do for this is add an occlusion texture. And then I like to use this occlusion minimum instead of having like a multiplier. I think after this we'll be finished with all the surface data, which is kind of nice. Excuse me. Okay, and then I think all I have to do is sample it. Yeah, and I know this is not really very efficient because we could pack the occlusion into another texture, but this is how Unity does it in their default lit shader. So I'm just kind of keeping it the same. Probably for me, since I use the metallic workflow, I would just pack occlusion into the metallic map, but oh, okay. I was curious why it froze, but it's because I opened a C# file. The first time I open C#, I think it does some kind of parsing and is kind of slow. So this is what I was looking for. Alright, so let's add an occlusion texture to our ground. I need to get some better textures to show this, but yeah, so it's the green channel, and so you can see that has different stripes. It's not as affected by the baked lighting. And then we can bring this up to kind of remove the effect of it. Let's just leave it, I don't know, something like that. Okay, so yeah, pretty simple stuff. Let's add support for it to the other version. And it works the same, so. All right, we're good. Okay, so let me blow my nose real quick, and then we'll continue with this. Okay. All right, so occlusion. Let's return to occlusion real quick. It's useful to vary occlusion over a mesh. So I guess concave areas and other corners don't receive as much global illumination. We can do this with an occlusion texture. Add another property to your shader, as well as a minimum occlusion value, so we can tweak the strength per material. Add these new properties to the common HLSL file in the forward lit fragment function. Sample the occlusion texture and then use the green channel in a LURP function to interpolate between the green channel and 1. This is equivalent to 1 minus green time 1 minus the green channel times the occlusion minimum. Is that actually equivalent? It's kind of hard to do math on stream. I think it is. So interpolate is like it's like the minimum plus the min, or the max minus min times p. So we basically want to see if this equals 1 minus okay, I don't think it is equivalent. I don't know. So we want to see if this equals 1 minus p times minimum. Or we want to see if it's equal to the max minus the minimum times p, which I don't think is true, but so anyway, I don't know why I'm wasting time on this, but so max times p minus min times p. So then it would be min. Okay. So it would be p minus 1 times min plus max times p. And then if okay, well anyway, yeah, I guess we don't really have to worry about this. Okay, so I was just trying to think of another way to explain this, but okay. Anyway, probably easier not really to use math at this point. So this is like bringing. Okay, this brings up the minimum value in case things look too dark. All right, so test. I guess I should also mention, you might also wonder why use the green channel. This is because, or this is so, if you work with the metallic workflow, The occlusion data can be on the same texture. If you never, or if you don't support the specular workflow at all, you could just pack the occlusion into the metallic smoothness texture by default, or even put occlusion as the alpha in the emission texture. Regardless, the lit shader does it this way, so I will in this tutorial test it out in Unity. Okay, so I think we're done with occlusion. So 15 to occlusion. Okay, so next up, okay, so we have the meta pass because I want to do baked emission textures. Back when we added the emission textures, or did I actually mention this? I don't know. Oh yeah, it says we'll tie some with baked lighting. I mentioned we can tie in the emission glow with baked lighting. This is done with something called a meta pass, which provides the light mapper with information about our shaders surfaces. Okay, let's write it. Okay, so this is actually going to be a pretty big thing, because we have to add a whole new pass, and we also have to change the way some of the code is structured. So first, let's just write the meta pass, I guess. So new item. Smilet meta pass HLSL. And we'll start by copying this whole thing. Okay. So the meta pass is kind of complicated because they changed a lot of how it works in 2021, or yeah, 2021.2. So I wanted to support both of them, so we kind of have to duplicate code. But okay, and then yeah, for some reason you also have to include this file. But okay, let's delete that. Okay, so we don't, I'm not going to worry about editor visualizations yet. No dynamic light maps, although Okay, yeah, I don't. Yeah, we'll just set that to 0. Yeah, so no visualizations. Yeah, then static, we'll just set this to 0. No visualizations. Okay, we're not going to have custom lighting yet. I'm just reading all that to see if there's something I need to delete. Okay, yeah, so we've got to explain all that stuff. And then in the shader, we have to add the new pass. At least this part's not that complicated. Oh wow, I'm surprised the formatting carried over that well. Just a couple little mistakes. Except we're not going to have editor visualizations, so we can just get rid of that. And yeah, no custom lighting. Oh, I do want to mention, yeah, there's this weird thing that for the light mapper to work correctly with baked shadows, you have to call the alpha cutout this, and then also alpha cutout materials have to go in the alpha cutout sorting group, which can sometimes mess up batching in other areas, but that's just how Unity's done it. So I need to, let me write a note to do that. Okay, let's do the cutoff hard coding. I think I mentioned that when we first did alpha cutouts, but now it's actually relevant. Then the inspector, I did. Okay, I do set it to the transparent cutout. Oh, but that is another thing I have to do, actually. In order to get global illumination to work, you have to assign this flag, and there's no way to do it except in the script, which is kind of annoying, but thankfully we can do it in our material inspector. Oh, yeah, it's just this line. Not too fond of that song. Okay. Oh yeah. Okay. I need to. So this create surface input is really just all of the from the forward pass, just this section. which I think should be pretty much identical to the final shader. I don't know why I wrote this out. I guess because I don't zero. I don't know, I don't think that really matters. Don't really want to explain clear coat. Okay, so there we go. So if I bake now, nothing really should change. So I need to make an emissive material to. That's not how you spell that. Okay, so this, I'll just turn, okay, I'll turn off the occlusion, oops. And give it a really strong emission. Okay, so this is static. Let's put it somewhere kind of close, so that maybe it'll be affected, and then give it the emissive material. Let's name these actually. So this will be emissive, static, shadow, caster. Okay. I still didn't spell this right. Okay, so since this is static and it's emissive, it should bake lights onto the surrounding materials. Can increase the HDR just to make sure. Okay, so generate lighting. Okay. It did not. Oh, thank you AMD for interrupting my stream. Okay, I mean, I set the emission here. I know it's kind of like, I know the way Unity does it is a little strange because they let you, you know, specify the emission here, but it doesn't actually happen unless you set this global material flags, which I thought we just did. Is there something else I have to do? Maybe it doesn't work with non-directional modes, which would be a little annoying because I've already... I guess we could just explain that before we go to this part if I have to. Let's see, maybe it works in 2021. And then I need to add this script. Okay. I don't know why my fingers don't want to type a missive. Okay, so it didn't. Maybe it did because there's this dark area over here. Maybe that's the shadows. Oh, well, no, they were baked in direct mode. I'll just like put it inside. You should at least get some around the edge. Don't see any. Yeah, saying there's no emissive. Although I don't really support. I don't support the visualization, so that might not be. Yeah, I think that's it's like some occlusion. Okay, well, let's see. Unity baked emission. I'm pretty sure I got this working in my test scene. So I'm probably forgetting something, but... Let me see here. So mission is showing up in the debugging view. Alright, well, let's see. Maybe we can find mist of light not baking. Maybe this will tell us. Direct intensity. Ambient and direct intensity is right there. Let's turn that up. Okay, no, that doesn't do anything. Maybe baked in direct doesn't work with mist of lights? No. I mean, you don't really should be like right over here is where the sphere is. You don't really see a shadow like you do in the other version. Okay, now you do. I think that's basically just the shadow from the blue light. Okay, let's see what this says. The texture is not index-based texture and is not available when using progressive. Please go to the instance you wish to debug and select the light map on the mesh renderer. Probably has something to do with this. Do I have to like save it maybe? No, nothing. Don't really do anything else here. Okay, well okay. In this project, I thought I had it all working. Let me see. Do I have... I mean, I guess that's what I should do. Let's see. Yeah, that's what I should have done from the start. I'll make a duplicate of this. And we'll use... just a normal lit shader with emission. And then apply it. Oh, that's because the default color is white. Is the yeah? So if I want to make it neutral gray. Let's see if this. Okay, it does. So it's something with my material, which I guess is good to see. Okay, so it's not the setup of the light map, it's something with my material. What could that be? Okay, I set the emission here. I guess take a look at this meta fragment function, which I think. Hey, Catamilla. Yeah, emission color and then emission amount. I think I mean, I have those both already because yeah, I have the emission and then the emission tint. So this is the 1, 2 actually. Oh, it actually was fine how it was, but whatever. Okay, that's kind of interesting. It doesn't even, the emission doesn't show up. Oh, we can't, but that's because we don't have visualizations, I think. I mean, is that what's causing it? Oh yeah, so I want to see this meta fragment. Let's see if I can find where it is. It could be here. Oh no, it's different. Unity meta fragment. Well, that just calls that. Oh, here. That's not it. It just calls Unity meta fragment. But I'm trying to figure out where's that, just the normal meta fragment that I'm getting. Maybe, what about the lit shader? So it calls universal fragment meta. Which think was... Okay, so this is the lit shader, the fragment pass. Okay, so universal meta pass. Do I have that one open already? In the universal shader library. Okay, so this one has universal fragment meta, and it calls this unity meta fragment, which is maybe in the meta input. This is meta vertex position, but this calls the meta pass in the core shader library, which is, I don't know if that's it or not. Okay, so that was it. So I also call the meta input in the universal. And I call that meta vertex position, but then it changes. See, that's the problem is, yeah, the meta pass has changed a lot in the next version. But I don't know where this meta fragment is, which I probably should have put a comment. Okay, so let's... So this is in meta input. Okay. Okay, this is the vertex position. So vertex position, okay, is in there. So where's this unity meta vertex position? Oh, it's actually what's called here. That is in the core shader pass. Or shader library. What am I looking for? Yeah. Okay. So unity meta vertex position. Close some of this stuff. Okay, so that's what I call in 2021.2. What about here? Does this exist in the core? Okay, no, because that meta pass doesn't even exist in the core shader library at this point. Okay, so well, that makes sense. So the meta fragment is just in meta input. Okay, so this is in core meta pass. Okay, so let's add these little, oops. And then this is in meta input, except it's not in 2020 in 2020.3, and I don't know where it is. Okay, so what I'm looking for, meta fragment. Maybe I'm just missing it. So there's this Unity meta fragment, but how come it doesn't throw an error? Okay, so that function's gotta exist somewhere, but where? This kind of bug is. This is why it's annoying to work with this shader libraries, because it's really hard to find where data or functions are defined. Okay, so I think what I'm gonna have to do. Okay, let's just search for this in the entire solution until I find where it's defined. Oh. This is where it's defined. So all they did was just rename it with a define. Okay, so actually I've been staring at that. And renamed Unity meta fragment. Okay. It is renamed Unity meta fragment with define in 2021.2, which is located in core metapass HLSL. Okay, so this does a bunch of stuff which don't really have to worry about. Just doing editor visualization, and then but it just returns basically our wait. So what's this? Okay, so what does it actually do with our input? Let's see. So in. So this is not okay. So this isn't defined. So it goes through here. So fragment control if albedo, then it does. Oh, I see. So it probably makes two passes over here. Once to make an albedo texture, and then once to do an emission texture. Okay, and then here it's correcting for a linear space and everything. Okay, so that's normal, I guess. Oh gosh, I've gone over time. Well, I hate to leave on this bug, but I don't really know what I've forgotten, so maybe I'll try to. I don't know if I'll have time, but I like to fix it before next stream so we can get to something else. But yeah, sometimes you run into these kind of bugs and it just takes a little bit of time to figure out how URP handles it. But anyway. Oh, I need to update. But anyway, you can see that even though we're returning emission like we're supposed to, we're missing some other little flag somewhere that's making Unity not recognize our emission. So I'm just going to have to go and look and see what that is. But anyway, thanks everybody for coming by and chatting. I really appreciate it. Probably won't be live again until Saturday, but like I said, hopefully I'll fix this bug and we'll probably work some more on this, work on some more lighting stuff. But until then, I hope you have a great week. I'll put some links in chat if you enjoyed the stream and you want to connect with me on social media. Be sure to check out my YouTube channel. I have a bunch of shader tutorials there. And yeah, I guess that's it. So yeah, have a great rest of your weekend, and I'll see you Saturday. Bye-bye.